Right now, as you read this sentence, your brain is lying to you. Not occasionally, not by accident. Every single second you're conscious, your brain is constructing a fabricated version of reality and presenting it to you as truth. The sounds you hear, the colors you see, the feeling of the chair beneath you, none of it is what you think it is. And the strangest part? This isn't a malfunction. It's the whole point. We've spent thousands of years assuming the mind works like a camera. Something happens out there, light hits your eye, signals travel inward, and the brain produces an accurate picture of the world. It seemed obvious. It seemed so obvious that almost nobody questioned it until fairly recently. For 3.8 billion years, life evolved by responding to the environment. React fast enough, survive. React wrong, die. Simple. And for most of that time, the lag didn't matter. A worm sensing vibration, a fish detecting shadow. But then something strange happened about 300 million years ago. Brains got complicated, got slow. Because processing information takes time. And time, when something is trying to eat you, is the one thing you don't have. The answer evolution came up with is far stranger than you'd expect. In the 1990s, a neuroscientist named Karl Friston at University College London began developing a model that would quietly upend everything we thought we knew about perception. His framework, which he called predictive coding, described the brain not as a passive receiver, but as a prediction machine. A hallucination engine running in controlled, careful loops. Here's what he found. Your brain doesn't wait for the world to tell it what's happening. It's already decided what's happening. Right now, before the light from this screen fully processes, before the sound waves from outside fully resolve, your brain has already generated a model of what it expects to be there. A full, detailed, three-dimensional prediction of reality. And then, only then, it checks the incoming sensory data against that prediction. Think about that for a second. You're not seeing the world. You're seeing your brain's best guess about the world, updated milliseconds at a time by error signals. Friston called these updates prediction errors. When reality matches the model, no update needed. When reality surprises you, the brain has to recalibrate, but the model comes first, always. This delay, somewhere between 80 and 200 milliseconds depending on the sense, seems tiny. It's not. 200 milliseconds is enough time to step off a curb and realize the car wasn't where you expected. It's enough time to say the wrong word and already be past the point of stopping it. The world you're experiencing right now is 80 to 200 milliseconds in the past. But here's the part almost nobody talks about. Your brain doesn't just predict what's out there, it predicts what's relevant. It filters ruthlessly. Billions of sensory signals arrive every second. The brain selects maybe 50 pieces of that information to push into conscious awareness. The rest gets discarded before you ever know it existed. The feeling of your left foot inside your shoe, you weren't aware of it a moment ago. Now you are. The brain decided to surface it the second you read those words, but it was hiding it from you before, because you didn't need it. This is where it gets strange. In 2007, researchers at the University of California, Berkeley, published a series of studies on something called change blindness. They showed subjects videos in which significant objects, a person's sweater, an entire truck in a scene, the color of a wall, were swapped between cuts. Most subjects noticed nothing, not because they weren't paying attention, because their brain's model of the scene was so confidently wrong that it never generated a prediction error. It expected continuity. It got continuity. Never mind the truck. And it gets deeper. The same year, Anil Seth at the University of Sussex, now one of the world's foremost consciousness researchers, gave a lecture that reframed the entire question. He argued that what we call normal perception and what we call hallucination are not fundamentally different processes. They are the same process. In both cases, the brain generates an internal model of reality. The difference between a sane person and someone experiencing psychosis is not the mechanism. It's the accuracy of the prediction. Let that sink in. When a person with schizophrenia hears a voice that isn't there, their brain is doing exactly what your brain does every moment of every day, generating a prediction about what's in the environment. It just happens to be generating one that doesn't match the incoming sensory data. And crucially, because the prediction is so strong, it overrides the error signal. The brain doesn't recalibrate, it doubles down. The voice stays. Seth called perception controlled hallucination. The control is what most of us have. The hallucination is what we all have. So that settles it, right? Well, not quite. Because this raises a problem. If your entire reality is a model, how do you ever know when the model is wrong? How does anyone? You can't step outside your own perception to check. There's no God's eye view available. Every correction you make to your model is itself made by the model. You're checking your answers with the same brain that got them wrong in the first place. The philosophers have a name for this, the hard problem of consciousness. Friston and Seth have a different answer. They say the brain is a Bayesian machine. It updates probabilistically. It weights the evidence. New sensory data that's strong enough, consistent enough, loud enough, it can break through the model and force a revision. This is why magic tricks feel impossible to understand even after they're explained. Your model got fooled.
Your model doesn't like admitting it. The emotional resistance you feel is your brain defending its predictions. This is also why trauma is so physically real. When a threat becomes so overwhelming that the brain's model updates catastrophically, the world is dangerous, people are unpredictable, nowhere is safe. That's not a thought, that's an architecture change. The model has been rebuilt around a new prediction. Every subsequent experience gets filtered through it. Now here's what's strange. Evolution didn't build this system to be accurate. It built it to be fast. The whole point was to act before the full information arrived. The fastest animal doesn't always win, but the fastest decision maker almost always does. Accuracy was a later optimization. Speed was the founding principle, which means every brain on this planet, yours, mine, your most rational friends, the most careful scientist who ever lived, is running an architecture optimized for quick, mostly accurate guesses. Not truth, not accuracy, survival-calibrated prediction.
So here's what's actually happening to you right now. You are sitting inside a model that was built from the first sounds you heard as an infant, refined through every touch and shock and disappointment and delight of your life so far. When you look at a person and feel instantly that you trust them, or don't, that's not intuition. That's your model pattern matching against 30 years of similar faces, similar voices, similar situations. When you walk into a room and feel inexplicably uneasy, your model has already processed 6 subtle cues that your conscious mind hasn't caught up with yet. You're never experiencing the world raw. Nobody is. Nobody ever has. The light that hits your retina is real. The neurons firing are real. But the world you see, the world you move through, the world you make decisions in, that is an interpretation.
A story your brain tells itself, confidently, every moment, just fast enough that you never notice the seam. The strange gift in this is that it means consciousness is not a passive window. It's an act of continuous creation. Every moment you're awake, you are building the world you inhabit. Most of it is built from what came before, but not all of it. The model can be updated. That's the whole system. That's always been the whole point.